Hello everyone, so in this video, let us talk about interfaces. So it's a very important concept, so stay tuned on this particular video. You will learn a lot of things about interfaces with Golang. So before that, I have written down a pre-written code and you will understand all of that if you have gone through my previous videos. I have three important videos you have to first understand before going to this particular video. The three concepts are, you have to first understand structs, okay? We have used structs here, I have a video for that. You have to first understand also what all are methods, okay, like we have a video for that, and what these receivers are, we have talked about in methods only, and that's it, okay. Then we'll move down to interfaces. Now what this actually is, like, we have to first understand what I have written here, and then we'll move down to what are interfaces and why they actually used. Okay, so giving down a very small introduction, that we have talked about structs. Okay, structs are, you can say, a type which gives us the functionality to combine or encapsulate different fields of different data types, or maybe of structs also, in which you can say that I have a square which is a struct and it consists of a, let's say, length. So it's just encapsulate all the properties of a square. Okay, you want to encapsulate the properties. Okay, a square consists of length, circle consists of radius, all of that, and then what you have done is that to calculate out area of a particular, let's say, square or circle, what you have done is that you have created a square and a perimeter functions now with a receiver. So these are methods. But receiver, what it actually gives us the functionality is that this function call is only done on square type of objects, which has been initialized using this particular struct, which are square type. So this, take this as a receiver and then call out the area. Similarly, the perimeter. Now, what you can directly understand from here is that now you have the same function which you can call on different type of, like, you have differentiated the same function based upon the receivers. Now, what you can see directly here is that I've created a square object, okay, which has a length, and we have stored that in this variable. Again, we have created a circle object which has a radius and stored it here. Now you can directly call the same function, okay, r.area and like c.area, which will automatically understand this is a square. You can say square area because it has a receiver of a square, so it will automatically go here, calculate the area, and here it is a circle, so automatically calculate the area for circle. Okay, pretty much simple. We have understood all of that. Thing is that these structs are encapsulating or is a collection of these fields, okay, but it doesn't have the functionality to, because in classes we can, because as you have learned that Go doesn't have classes, but in, like, when we have classes we can encapsulate these methods. We have the functionality to encapsulate methods also, method signatures, as well as these fields. So we can encapsulate these fields in struct, but where we can encapsulate these method signatures for interfaces. So interfaces is used to encapsulate, or is just a collection of method signatures. Now you might be understanding, like, why method signature is actually used and why it is like a functionality there. Like, what's the first case use of this? Let us first try to build an interface and then you'll gradually understand why it is used for. So interface is also a type. You have to first give a type. So now interfaces gives us a functionality to encapsulate methods which are common to different, you can say, objects. Okay, so we can see that we have different structs. We have a struct of square and circle, and both of them are shape. So we can make a shape interface. Now a shape interface, you can write down method signatures. So what does a shape consist of? A shape consists of an area and a perimeter. We have calculated here. So you can directly write down these, you can say, signatures here. Now you can see that I have not given any receiver here. Now what you can see here is that, like, still I'm not understanding, like, why I've created this, like why I've used this. The thing is that any struct which I have in here, if it implements all the functions of this interface, then it automatically become shape type. Now in different languages we have to use the keyword implements. Okay, this particular interface implements these methods, but Golang, like, is intelligent enough to understand that if all the functions provided by a particular interface is in like is you can say implemented by a particular struct or object, it automatically inherits the properties. So now, because square has a function of area and perimeter, it automatically become a shape object. Like it has the properties of a shape. Similarly, shape type, it's now become a shape type. So similarly, circle is also having a shape type. So what you can directly do here is, that I can create, let's say, an array of shape. Okay, and in that, what I can do is I can create, let's say, a square of length 22, and let's say another circle of radius, let's say 12. Is it fine? Okay, what's there here? Okay, so we've created an area, we've created a perimeter, we have created these things, that is fine. Area, perimeter. And this is this. Okay, now we have, okay, my bad. So we have to create an array, slice like this. So slice of shapes. Okay, that's fine. Yep. So what you can actually understand here is that we have created a slice, okay, of shapes type, and now we can put, like, it will automatically, we can create a slice of a shape type, and you can now directly insert out objects of square and circle, because it will automatically understand that because square and circle has these functions, it is actually like, and these are, or like these functions are of the interface of the shape type, so it is automatically a shape type. So you can now create like a slice in which you can insert objects of shape type, that is square and circle. Okay, I hope you are with me like 60-70%, but I will give you one more example so that you will now be with me like 100%. Let's create one more struct. Let's create a equitriangle, like equilateral triangle. So equitriangle, triangle. Okay, and it has, let's say, a length, and it is a fucking float 64. Okay, so we have again a shape that is equilateral triangle, and it has just a length. And now what we'll do is that we'll just give the functionality to create a perimeter for equilateral triangle. We just have the perimeter function, in which, what's the parameter of equilateral triangle? 3 into the sides, 3 into e dot length. That's it. Now, because this equilateral triangle is again a struct, but it only implements one of the functions of the shape interface. So does it become shape? No, because to become a shape type, it has to implement all the function signatures, like all the functions provided by the shape interface, but it has only implemented one. So can I insert, like, whether this equilateral triangle passes all the like checklist to become a shape? No. So if I just create an object of equilateral triangle, let's say equilateral triangle, and try to insert the length, okay, let's say of length, let's say 54, inside this shape's slice, it is giving an error. Because why it is giving an error? The error you can directly understand is that you are using equilateral triangle as this type because of the type shape, but it doesn't implement a function that is area. It is only implementing the perimeter function. It is not implementing the area. That's why you cannot insert it. It is not qualified as a shape, and thus you cannot insert it inside a slice of shapes. That's it. So if you just implement one more functionality, one more function, it will automatically comes under shapes, and you can now insert it inside here. That's the overall idea. That now you have given a wrapper around it. You have given that what all we can use. So if anything that has, or like it follows these particular signatures, can be used or categorized under this particular interface, and you can use it out. Okay, that's the overall idea what we can do with interfaces. We have different use cases, we'll talk about that throughout this course, but I hope you understand what is the overview, like what interface is. Now when any object comes under a particular interface or particular type, what you can do is that if you just do it, so now if you just do fmt.println also of this sh, it will just print out these particular shapes. So it is 15. So these shapes 32 and 12, these are the shapes, and this is the area of these which was called for these things. Okay, but there's also one thing which you can do, that because now we're talking about these shapes. Okay, shapes is, you can say, a wrapper around of this. You can directly call a function. You can use functions, let's say of type, you can say calculate, and then it will take as a parameter, what it takes, it will take shape object. Okay, it will take an object of type shape, and what it will do is that it will just do print of s dot, you can directly do parameter, because obviously shape, you directly know that shape has these particular methods, so you can directly access this method. So you can just do fmt.println of s dot area. Now instead of doing this, you can actually just do you can actually just do s, okay, maybe you can just do calculate, you can just do calculate, and in this calculate you can actually just pass out any shape. Okay, now square is also shape, circle is also shape. You cannot pass out equilateral triangle because it's not like passing out all the checklist for becoming a shape, but you can pass out like a square. Okay, and it is perfectly passing out, so giving no error. You can just print out, and okay, this is, if it is not used, we have talked about that. That's it. It is directly just using out a shape as an input, which you have used it, and automatically calculate out its perimeter and area of this particular square, printing it out. Okay, so it takes a shape type. So that's the overall benefit, that we can like generalize it. Okay, we have to just understand that any object which follows or like implement all the methods provided in the interface just becomes this particular type. Okay, and then all other fields also, if you just run on the implementation of them, comes under this particular type. So now you can run on common functionalities over the top of that. Okay, I've written a common functionality in which both of these you can say structs, okay, or types which follow this particular interface comes under, and you can just manipulate or play around with them. So that's the overall idea of interfaces. We have different videos coming all together about interfaces and where it is all used throughout this whole project. So we have different projects coming out also, and which we learn about different interfaces as well. But that's the overall idea how we can use interfaces. And if you still haven't out, you can mention on in the comment box of this particular video. I will see you in the next one. Coding, and bye.